last lesson in our unit of analyzing functions, we talked about what domain and range looks like on a graph. Okay. Now we're going to look at identifying domain of a function from its equation. Okay. So what you should be able to do by the end of today is just that. To identify the domain of a function from its equation. All right. When we're thinking about a graph, okay, let's say we're looking at f of x equals x or y equals x. The graph of that is going to look like this, right? There's our axes, and here's our line. So the domain and the range of that is negative infinity up to infinity. It hits all the x values, it hits all the y values. So when we're looking at a function, we're going to assume that the domain is going to be negative infinity to infinity. All right, then we need to start thinking about exceptions. So when would an x value not show up on a graph? Well, if an x value makes a square root negative, it's not going to show up on a graph. When an x value makes a fraction, the denominator equal to 0, it's not going to show up on a graph. For example, if we had the function f of x equals the square root of x, when x is negative 2, we have the square root of negative 2, that's going to be an imaginary number, it's not going to show up on a graph. Okay? If we have the function g of x equals 2 over x minus 2, when x is 2, that's going to be 2 over 2 minus 2, which would be 2 over 0. Anything divided by 0 is undefined. Okay? So, can't have negative numbers in a square root. Can't have 0 in the denominator of a fraction. Alright, so let's look at some of these examples. So, start by assuming that it goes from negative infinity to infinity, the domain, and then look at restrictions. So here, assume it goes from negative infinity to infinity, and then ask yourself, does it have any square roots? Does it have any fractions? For the first one, no. So the domain of this function is negative infinity to infinity. For number 2 here, does it have any square roots? Does it have any fractions? Otherwise, it doesn't. So, again, our domain there is going to be negative infinity to infinity. Let's look at 2.a. Okay? 2.a, f of x equals square root of x minus 4. Again, assume it goes from negative infinity to infinity. And then think about restrictions. Does it have a square root? Yes, it does. So, we can't have a negative inside the square root. So that means we want everywhere where x minus 4 is greater than or equal to 0. So we want everywhere where x is greater than or equal to 4. Okay? Because that's going to be where what's under the square root is positive. So, interval notation, that would be 4 all the way up to infinity. Alright, let's look at another one. 2.b, we'll say g of x equals 2 over x minus 3. Okay? Assume it's negative infinity to infinity. And then think about restrictions. Does it have any square roots? No. Does it have any fractions? Yes. So we don't want to include x's that make the denominator equal to 0. So, if we solve that out, when x is 3, it makes the denominator equal to 0. So we don't want to include 3. So what that looks like in interval notation, we want everything from negative infinity up to 3, not including 3. And we want everything from 3 to infinity, not including 3. So we want everything besides 3. Alright, let's look at m of x down here. Assume negative infinity to infinity for the domain, unless there's any restrictions. In this case, are there restrictions? Yes, there are. Is there a square root? Yes, there is. So, let's look at the square root first. We can't have a negative inside a square root. So, we want to know when x plus 5 is greater than or equal to 0. Subtract 5 on both sides. And we have all the numbers when x is greater than or equal to negative 5. So we just cut off of our domain everything less than negative 5. Does it have a fraction? Yes, it does. So we can't include the x value that makes a fraction equal to 0. So when is the square root of x plus 5 equal to 0? Well, you might be able to see that already. Square root of 0 is 0. So when x is negative 5, the denominator is going to be equal to 0. If we wanted to solve that, we'd square both sides. Then we'd have x plus 5 equals 0 squared is 0. And subtract 5 on both sides. So we know that x cannot be negative 5. Okay? Combining those two restrictions, we only want stuff when x is greater than or equal to negative 5. And we can't have negative 5. So we're going to start at negative 5, not include negative 5, because the fraction doesn't allow that. And we're going to go up to infinity, because we wanted everything greater than or equal to negative 5. Alright, at this point in the video, here are 3 more examples. You guys go ahead and try these on your own. Pause the video, turn it back on when you have finished it, and we'll go over it. Alright, so for number 4 here, what restrictions does it have? Well, it has a square root. So, we only want everything when what's under the square root is greater than or equal to 0. We can't have a negative under there. Subtract 3 on both sides, so 2t is greater than or equal to negative 3. Divide by 2, t is greater than or equal to negative 3 halves. Write that as interval notation. It's a greater than or equal to, so we want to include negative 3 halves, and we want everything bigger than it. We want everything up to infinity. Look at the next one. What restrictions does it have? It has a fraction, so we don't want to include when the denominator is going to be equal to 0. So solve that, subtract 1 on both sides, then divide by 2 on both sides. So the denominator is equal to 0 when x equals negative 1/2. So we don't want to include that. So we want everything from negative infinity up to negative 1/2, and also everything from negative 1/2 up to infinity. So everything except negative 1/2. Alright, let's look at the next one. Think about the restrictions. Does it have a square root? Yes, it does. So we only want stuff that's going to make the square root positive. Add 4 to both sides of that inequality. 3t is greater than or equal to 4. So we only want numbers when t is greater than or equal to 4/3. Alright, now let's look at the denominator. We don't want x values that are going to make the denominator equal to 0. Then it would be undefined. So if we divide by 2 on both sides, we don't want when x is 0. So we want everything greater than or equal to 4/3. We don't want 0. So combine those, and in interval notation, it'd be from 4/3 to infinity, because we want everything bigger than that. So that better not include x is 0, and it doesn't, so we're good there. Alright, so you guys should be able to identify the domain of a function based on its equation. Again, write down any questions. Come to class prepared tomorrow. Have a good night, guys.